Okay, we're going to do the law of sines. It may be a little bit of a longer video because it does cover a lot. You use the law of sines mainly when you don't have a right triangle. It can be used to solve any triangle. It doesn't have to be a right triangle. And here we've got a picture. What the formula is proportions. And it says that the sine of A over little a will equal the sine of B over little b. And that will equal the sine of C over little c. So if you know two angles in the length of any side, such as an angle side or angle side angle, or if you know two sides in an angle opposite one of those two sides, then you can use what we call side-side angle. Now that doesn't work with congruence, but it does work with the law of sines. So let's take this first example, and there will be more videos with these examples. I have a side, and a non-included angle. So I get to use the law of sines here. And do you see how I know this A and the angle opposite, the side opposite? I can write this as sine of A, which is 115 over the leg opposite 20, will equal, and let's just say I'm trying to get the angle B here. And the reason I want to get the B here is because I have an 11 across from it. And I would have to have that. I couldn't get C yet because I don't have anything under the C. I don't know C or the segment opposite of it. So I can say sine of B, which goes with this 11. So that's kind of like this part of the proportion. All right, let's cross multiply. We have 11 sine of 115 equals 20 sine of B. Okay, trying to get sine of B alone. So we're going to divide by 20. And the sine of B will equal 11 sine of 115. So 11 sine of 115, make sure you're in degree mode, hit equal, and then divide by 20. And you get 0.4985. So approximately 0.4985. Okay, now that tells me that sine B equals this number. What I've got to do is find the angle itself, and I have to use the inverse. So I will say angle B equals arc sine of 0.4985. Okay, you may have to go back and look at previous videos. This builds, and you have to look back at those. So arc sine of 0.4985 is 29.9. So angle B is approximately 29.9 degrees. Right, so let's go put 29.9 degrees here. Now let's go ahead and find angle C, since that would be easy. All I have to do is add these together and subtract it from 180, or say 180 minus 29.9 minus 115. So measure of angle C is 180 minus 115 plus 29.9, or 180 minus 115 and then minus 29.9. which is 35.1. Okay, and that one also has been rounded off. Okay, now the only thing I'm missing is this leg here. I have both angles and I need this leg. All right, I can still use the law of sines to do that if I'm looking for this leg, because now I know this angle. So let's take that sine of 115 over 20 again. Sine of 115 over the opposite 20 equals, we're looking for this little c here, so sine of 35.1 over the little c, which is what we're looking for. We call it little c because it's opposite of the big C. Okay, cross multiply. We have C sine of 115 equals 20 sine of 35.1. Right, to get the C alone, I'm going to divide both sides by sine of 115. Have to be very careful putting this into your calculator. If you're using Desmos, usually that's a little bit easier. But I need all this to be put in the calculator before I hit divided by that. So let's go 20 sine of 35.1 and then hit equal. Then divide by sine of 115. And that's 12.68, so that is approximately 12.7. So my final answer is 12.7.